last lecture, I failed to record the video, so I just put the part-time video to the website. So you may feel a little bit weird, but the contents are same. Today we will complete L2, okay, lecture 2. Wait a second. Oh, in assignment 1, there are 2 problems. The first one is on question C of assignment 1, and the rotating speed is not given. So you should use the same motor speed as A. Okay. So for this part, so for C, the motor speed, also 600 RPM. Okay, and the other problem is I don't know whether you have found this. So the rotation of this wheel is counterclockwise. This should be the correct one. Okay. Oh, sorry, forgot something. Okay, one more time. So for assignment 1, question C, the motor speed should be 600 RPM, so that you can calculate. And for another, the rotation of this wheel, the middle wheel, okay, this drum, it should be counterclockwise. But in the original version, it is clockwise, right? In the green arrow, it should be rotate in this way. Okay, and that's it. Okay, as suggested by I would like to give some hints. Okay, let's look at this question together. So this is a ground lifting machine. So this is the picture, right? And so it is just throwing greens into the air, okay, as with a quadratic path, right? So in a quadratic 抛物线, okay, quadratic path. And based on this reality, we need to calculate something. So we need to determine the maximum heat of the green that can reach when the motor speed is 600 RPM. So for one thing is the conversion between RPM and the other units, right? The conversion, unit conversion. So when it is RPM, So it means revolution, right, per minute. So revolution per minute, 1 RPM. If we want it to be something radian per second, RAD/S, right? How many radian per second? And to calculate this, you need to do like this. So 1 RPM is a revolution, right? Per minute. This per means divide, right? So per minute means divided by 1 minute, right? In 1 minute, it rotates 1 revolution, so it is 1 RPM. And we can change this revolution. Okay, so just delete it and replace with 1 revolution is 2 pi RAD, right? And 1 minute is we just delete this minute, replace with 60 second. So all the units we want just appear, right? The first one is RAD, the second one is S, right? Radian per second. So we calculate the number. We find 1 RPM should be 2 pi over 60, right? 2 pi over 60, which is pi over 30, right? Pi over 30 RAD/S, right? Radian per second equals to 1 RPM. That is the conversion. And if you need a 600 RPM, then times 600, right? And you got the rotation in radian per second, right? And you want to calculate the maximum heat of the grain, which means from the ground, what is the maximum heat? And we know the initial point should be here, right? Initial point here is here, which is 0.7 meter from the ground, right? 0.7 meter from the ground. So we want, for the question A, we want to know from the highest, right, to the ground, from the highest to the ground, what is this heat, right, in question A. So for this heat, you need to know the velocity at this initial point, right? The velocity here. So for this velocity, you need to know the velocity of the belt, a point on the belt, right? So to find the velocity, because on the belt, everywhere, the speed is same, right? So we need to know the particle velocity of a point on the belt. Right? It's a polar belt. And so how to find it? And later in this lecture, we will talk about this. Okay. So given a system like this, right, we have the driving wheel, the driven wheel, right, and there's the wheels, and how to determine their angular velocity and the velocity on the belt. Okay. This is one topic in this lecture, so you will know how to calculate. And once you know the velocity, and it has an angle which is 45 degree, right? 45 degree to the right top, which means this velocity angle, I just use a red color. So this velocity angle is 45 degree to the horizontal, right? 45 degree to the horizontal. Therefore, you know velocity in the horizontal and velocity at the vertical. And then at the vertical, you know there is a acceleration, right? Acceleration due to the gravity, right? So the acceleration is g, which is 9.8 meter per second. If you use 10, it's okay. Okay. by default, it should be 9.8 meter per second. Therefore, if we know the v vertical, and we can calculate the distance from the highest position, right, to this level, and then plus 0.7, we got the number. And then B and C, we actually are same. So what we want to know is just we just return back, right? And given the distance, horizontal distance is 16 meter to 20 meter, and we can calculate the velocity here, required, right? Once we know the velocity, we can calculate back to find the motor speed. Okay, that's it. And for question 2, we can also you can also do it after this lecture, because this is about velocity and acceleration, right? The propeller is rotation, so we want to find the rotation, the particle acceleration, right, of a specific point at a specific time, right? So last lecture we talk about how to find the velocity, and this lecture we're gonna talk about how to find the acceleration. And when you come here, and you will know how to calculate. Okay, let's come to the lecture note first. For the assignment, if you do not know how to deal with it, or has so you have no idea, totally no idea how to start, you can WhatsApp me, okay? Or after you do some analysis and some calculation and do not know and want some feedback, you can also WhatsApp me, okay? Take this chance, because you need feedback to learn. Just the one part. So you want to more break it down? Okay. Yeah, just one part, but you need to calculate 2 components, right? Okay, let's come back. And before we continue on the rotation, we have let's have a brief review and draw a roadmap on how to learn this part. Is the L2? Okay, we come to note 2. So where we are here, right? Okay, we just start from here, and okay, let's see. So have a blank page, and you can also have a blank paper in front of you, and let's see what are we gonna learn. So for 3302, so for the mechanics related subjects, I want you to do something, okay, to be a brilliant engineer. So you got a blank paper, and you can write down something about this subject from scratch, right? We do it together. So we are learning dynamics part, right? So and it's about a schematic. So here we can write down rotation, right? We have learned the rotation. So for rotation, we have learned the rigid bodies component, right? For a rigid body, the rotation, we have learned 2 things. The first one is alpha. The first one is angular velocity. The second one is angular acceleration. We haven't discussed it, but we already pointed out, right? And for a rotation, this is a rigid body. From a rigid body, we need to consider the motion of a particle, right? Of a particle or a point on the rigid body bodies. Okay, so for a point, we also has two items, right? Have two items. The first one is velocity. The second one we call it acceleration, right? When we use the light letter, it is point velocity, point acceleration, and we need to build a bridge between them, right? So once we know a once we know the rigid bodies omega and alpha, how to get the A and V on a point, right? And that's what we care about. Okay, so you can see all of these things are under rotation, right? And I can give you a larger map. Okay, all of these things are about rotation, right? And for the motion of a rigid body, we also have translation. So there's no need to be worried, okay? So because when you see rotation, okay, so complicated, and plus translation, it's gonna be more complicated, right? But translation is much simple, because in translation, every point moves together in the same way, same acceleration, same velocity. So it's easier. Translation plus rotation, okay? When translation and rotation happens simultaneously, 当这两个同时存在的时候 okay? And the rigid body do a general plane motion. Call it a general plane motion. Maybe you do not know what it is, but when we talk about the general plane motion, I want you to come back to look at this picture and see where we are, okay? So when we complete rotation, okay, and we will consider translation. So put them together and we talk about the general plane motion. General plane motion. So you can see in general plane motion, if we want to know the velocities and the accelerations of particles, we need to analyze two components. First one is translation. Second one is rotation. Actually, rotation is 99%. Translation just the last 1%. Okay. So in the complexity, and for the general plane motion, we're gonna use relative motion. Okay. Relative motion analysis. It has two parts. The first part is relative velocity. The second part is relative acceleration. Therefore, after we talk about relative velocity and relative acceleration, and here, okay, I just highlight this region and leave it blank means there are gonna be two formulae, okay, two equations here. Gonna be very useful, and we will give it next lecture. So this page is the kinematics part. This page includes the whole part of your midterm test. Okay. So when you pick up this page and see, if every part you can you can remind a example of a comprehensive question and know how to do the problem solving, and you will get a high grade in midterm test. Okay, so we finished the equation in this block first. Okay, so from omega to v, we know the equation, right? We know the formula. I just use red color. Okay, so if you want to know the velocity of a particle on a rigid body, and if in skew, okay, in skew analysis, skew method, we just use the omega times r, right? Omega times r. This is we call it a scalar method. Very straightforward, right? Just find the angular speed and just find the distance between the point and the center. Do the multiplication for the result. And if it is in a vector, right? In vector version, it is written as omega the vector cross r the vector. This r is ROP, right? From the center to the point we care about. So the V is also VP, okay? Also, we can add some subscription here, right? VP is omega times ROP, right? Same thing. And we call this method as vector method. Vector method. This is about the velocity, right? Velocities. And we also have accelerations, okay? So for acceleration, and what we will learn today, it's gonna be a little bit complex than velocity, right? So for acceleration, I just put the formula here, okay? Put the formulas here, and we will go in detail for each component, right? So I just give the accelerations vector version first, and you can also find it by yourself. AT, right? It has two parts, and the first part is angular acceleration cross r, okay, from O to P, and the second part is angular velocity cross velocity of point P. So this is the acceleration part, okay? And we also have its scalar version. Okay, we also have its scalar version. This is the vector version, right? This is the vector version. For the scalar version, it's a bit. We need to write it in two components. One is APT. The other is APN. And I will explain later, okay? And now you should know APT is alpha times R. You can see the similarity. So here is alpha cross R, right? Now, here is alpha times R. So this is APT, okay? This is the APT component. And later, this component is APN component. And we can write it as omega times V, right? VP. You can also write like omega square times R. You can also write it like velocity of P over R. Okay, R is ROP. Okay, so many familiar, right? And later we will explain. And do you find something in your memory from the middle school or before? Circular motion, right? All about the circular motions. But we just talk about the circular motion in a systematic way. Okay, so now we give all the formulae we use in rotation. So this one and this one. Okay, one is about velocity, and the other about acceleration. For the acceleration, we just use the red highlight. Okay. So at last, you will find what we learn in 4 weeks, right? In a month, it's just 1, 2, 3, 4, 5, 6, 7, 4 minutes. Okay, so in your before we come to the detail, and I can show you what it looks like when you face to a class test. Last year, the class test would be like this. You find is yeah, this is last year, not this year, okay? So last year's class test, we just have 4 simple questions and just give you as long as 2 hours to complete it. And yeah, the mean mark is not that ideal. That goes as expected. And you will find you will be asked about the driver ratios, right? Ask about the driver ratios in the midterm test. And this one better. So this is the driver ratio related, right? And you'll be given some gears and talk about the acceleration and velocity on the gear pairs. And second question is what we have done, right? Last lecture. So I just give here as a midterm test question. And given the omega and alpha, you'll be required to calculate a specific point, right? Also here, point C, right? Point C is velocity and acceleration. Okay, so given more carefulness, you can get a full mark for this question, right? Just do it step by step, right? So everything is simple. So and question 3, I just give you a very simple one actually, just to find the velocity of some points on a belt drive wheels, right? The wheel pairs, and find the acceleration magnitude of those points. And many of you got full marks. For the last question, it is about a relative motion. So I just give 2 rigid bodies, right? In this system, we have one, we have here we have 1 and 2 rigid bodies, and for these 2 rigid bodies, so we consider point D and point E, 2 points on it, and we find the velocity of those points. And actually, last year, the students maybe we do not have any ideal case. So upon press with 7, we do not have so much accumulations for more detailed questions. So this year, maybe we have 2 questions about relative motions. And yeah. Also, I will give more tutorials or more practice opportunities for you to deal with those questions. I'm fine. It's easy to pass, but not easy to get a full mark. Okay. And I hope you do not misunderstand, okay, what I'm saying. It's just very simple, and there's no need to learn 2302. Pay much attention on it. If you think about like this, you just have a try, and yeah, there will be a very huge reduction out of expectation. So just pay more attention. Make sure you can do it individually. Okay, let's come back to what happened. Okay, let's come back to our lecture and we continue. So we're gonna learn when we know the rigid body's motion. Okay, rigid body's motion. I mean omega and alpha. How to get the point's motion on it? Okay, motion of a point on it. And once we know the motion of a rigid body, okay, let's see. So for the particle acceleration in a curved motion, okay, in a curved motion, we can see some animation. Okay, before we start, I just let you to have a animation. Oh, there's no update. Wait a minute until okay, after class. First one is so when you see when someone drive a car, okay, this car is a rigid body. It has a circular motion, right? Circular motion moves in a curved path, not straight, right? Moves straight, but in a curved path. So when it moves like this, we can find there are 2 types of acceleration. Okay, 2 types of acceleration. The first type is the blue one. You can see the car, it just stops here, right? From a 0 velocity, right? It just start here. And it moves faster and faster, right? It speed up. It means there is a constant, right? Maybe there is a acceleration, okay? You pay attention to the blue one. There is an acceleration in the velocity direction, right? So you see, it moves at the beginning. It moves to the left, right? As time goes, it turns left and left and left. So you can see the blue one in line with the black one. The black one is the velocity. The blue one is the acceleration on the velocity. we call the blue acceleration as a tangential acceleration. Tangential means tangent to this curve. Okay, so this blue acceleration responsible for speeding up. Okay, as long as there is a blue acceleration, it means the car will speed up. Okay, it has nothing to do with the direction change. Okay, as a car turn left, to turn it left, you need another acceleration to change the direction of velocity. That acceleration is the red one. The red one. You can see the red one always point to the left-hand side, right? Point to the left-hand side means the car will move to the left. Okay? If there is if here we have a car, okay, at the beginning, and you will, if you inform, okay, we have a acceleration in this way, which is a tangential, okay, a tangential, and we have another acceleration, which is a t, sorry, a n, okay, we have another acceleration, a n. Based on these two accelerations, you should know, for one thing, it will speed up in this direction. It will speed up in this direction, okay? Because the existence of AT. The second point, the car will turn left or right, down or up, turn up, right? It will turn up because there is the other acceleration going this side. Okay, it will turn up, and as the car goes here, the acceleration, the normal acceleration. Why we call it normal? Normal means normal to the velocity. Okay, this is the velocity, right? And we always have an acceleration normal to the velocity. When normal to the velocity, it does not change the velocity magnitude. It changes the velocity direction. Okay, so we call it a normal. A normal here. And when it still speed up, and we still have a t here. T means tangential. Tangential is in line with velocity. Okay, one more time in Mandarin. Totally same. Okay, as I told you. 就是这辆车在开始的时候，如果有两个加速度，那有一个它是和速度平行的，那我们把它叫做切向加速度 AT。有这个加速度，车子才可以 speed up， 才可以加速，只管加速。那转弯怎么办呢？转弯我们有一个垂直的叫做法向，有垂直的意思，means normal。法向加速度就是和速度一直有一个直角的，这个加速度的存在是为了转弯的。Okay, back to English. So just to think about it. Do we have a circumstance that we do not have AT, but we have AN? Yes. So uniform circular motion, right? So when something rotates like this, okay? When something rotates like this with a uniform speed, right? Uniform speed. It does not speed up, right? No. Okay. always have a normal acceleration on it for this point, okay, for this square particle. We always have a normal acceleration going to the center, but we do not have a tangential acceleration. So if there's only a tangential acceleration, but no normal acceleration, what it should be?只有切向加速度，没有反向加速度，那就变成，那就成直线运动，对不对？它就不转弯了。Car starts from here, okay, and it moves, okay, to the left, and we only have at, same as the velocity, okay. We only have at. We have no an, okay, an no. So the car will have no acceleration to change the velocity direction, which means it will move in a straight line, okay, in a straight line. So that's the difference. Okay, with this intuitive points, we come back to the derivation, and although maybe you can get the every detail, however, you can understand what I'm saying right here. So let's see, in theory, how to talk about the particle acceleration in rotation. So if we have a curved motion, right? Curved motion means it moves along this curve, and we find, okay, so there is a velocity direction change, okay? At the beginning, it points to the right. And as time goes, okay, when we move a d theta on the curve, velocity becomes to this one. So we find the direction has a slightly changed. Also, the velocity, the magnitude becomes higher than before. Oh, sorry. Got it. Okay, so when a particle, where is a particle? Here is a particle, okay? The particle moves along the blue curve, okay? A circular motion. And it means this rigid body, where is the rigid body? The rigid body is this one. You can take it as a gear or a mechanical part, okay, mechanism part. And this rigid body has a rotation about its center, okay? It rotates about its center. It has angular velocity omega. It has angular acceleration alpha. Okay, it has angular acceleration alpha. And we see when the particle moves from here to here, and there is a slight change of direction, right? There's a slight change of direction. It also has a slight change of magnitude. So when you check the magnitude, you check the length of this arrow. Okay, at the initial time, the arrow is this long distance, and we compare to the initial. Okay, it's longer than before. Longer velocity arrow means faster. Okay, if this velocity arrow is very long, it means it's much faster than before. Okay, longer is faster before velocity. Okay, and we find there is direction and magnitude change. So the magnitude change is this part. This is the beginning. This is the d theta later. right? So from the beginning to d theta later, okay, we move. What did I do? I just do it in this way. So let's check it. Okay, in this color. Okay, in the green color. So originally it's here, right? And then it moves to here, right? We want to compare this velocity and this velocity, right? How to compare? We need to move them together. We need to move the second one or the first one to move this one to make these two vector has the same initial point. Initial point is here. Okay, move them together so we can compare these two velocities. When comparing these two velocities, we find, okay, there is we can take it as two steps. First step, it becomes longer, okay? It becomes longer than before. Second step, it has a direction change than before. Therefore, we have two parts. This part is the tangential. Oh, I forgot how to spell. Okay, just the T. Okay, and the other is the direction change. It's normal. Okay, simpler, right? So T for tangential, N for normal. Okay, two parts. And now we are engineer, right? We do not just analyze with words. We need to do it with numbers, right? With expressions. First one, how to get this amount? How to get this quantity? How to get this quantity? Actually, this quantity is easy. Slow down. Slow down and let me have a new page. You can also have a new page, okay? So at the very beginning, it is here, okay? As time goes, it comes to here, right? With a longer velocity, okay? With a longer velocity. And now we move them together and compare these two arrows, okay? The initial one, we call it V initial. And later one, we call it V initial plus dv, okay, plus dv. Dv means a very the change of v, okay. So we know the angle between them is d theta, okay, because the angle of the velocity always perpendicular to the radius, right? Perpendicular to the radius. As the radius change for d theta, therefore the velocity direction change d theta. Okay, so direction change is d theta. Okay, let's focus on this and continue our analysis. So as I mentioned before, it has two parts. First one, it becomes longer than before, this long, right? Secondly, it has a direction change than before, this long, right? So the dv, sleepy, right? dv has two parts. We have dv tangential, and this is dv normal. Dv normal. For the dv tangential, okay, for dv tangential, let's see what can we do. We can compare, okay, we can compare. How to compare? So before d theta, it is a v, right? We just use a scalar, okay? And later we talk about the direction. And later, after d theta, right? After d theta, it is v and plus dv tangential, right? dv tangential. So what is this value? What is this value? Actually, it's easy. We have learned it. At the beginning, the velocity, what is the velocity? We have learned this. The velocity is omega times what? R, right? And later, what is this velocity? It's omega, right? 變咗個加咗個新嘅 delta omega 係咪？新嘅 omega times R 係咪？We can use d omega, okay? Or to make it more rigorous, okay? I just please allow me to use delta to replace d, okay? Same thing, delta omega, okay? dv delta v. So, okay, so originally the velocity is this one. And as time goes, the velocity becomes this one. Okay, so what is the acceleration? Acceleration t is the velocity change, right? V plus delta v, right? V plus delta vt minus the previous velocity v, right? Over time change, right? Over time change. If you not sleepy, just repeat this expression. Okay? That's time change. And we do the calculation. V minus v eliminated, right? So we have delta vt over delta t. Okay. And what is delta vt? You will find, okay, as the numerator, it is omega plus delta omega r. So if we expand it, it is omega r plus delta omega r. And then we need to minus the original velocity, which is omega r, minus omega r, right? So simple, over delta t. And we have omega r minus omega r, nothing. We got a delta omega r over delta t. So delta omega over delta t, what it is? Not delta acceleration, it's angular acceleration, right? So it has a name, right? Angular acceleration. So this one, omega over t, right? Is delta omega over delta t when t is very small. So limit means when time is very small, okay? Limit delta t to 0. So delta omega over delta t is angular acceleration, okay? This part is angular acceleration. And we have r is a constant, right? So alpha r. Now we have the first one, at, which is alpha r. It's easy to understand, right? So how to explain? It means the rigid body rotate faster and faster because of alpha, right? Because here we have alpha, and alpha is not 0. It means it rotates faster and faster, speed up. So if a point placed on this rigid body, the point also moves faster and faster, and that's why alpha r. So this part responsible magnitude change, or to memorize, you can, or to remember this, right? You can use so it just speed up, right? Responsible speeding up. And the second one, okay, second one is AN, okay? I just give you 1 minute to discuss with your partner. And you can also interrupt by you can discuss. You can ask questions. Is it clear? If not clear, make sure you remember this two letters.
also about the additional acceleration and always change.
The angular, yes. For a fixed point, for a specific point.
I see that on the whiteboard pattern is acceleration and acceleration of acceptance and then also take
this one. What happened?
Originally, it's just horizontally that
Yeah. This acceleration only changes the speed. Okay, for the speed, faster or slower. The alpha r all only change the speed, does not change the direction.
Then this one is change the
This A, yes, A and the red one only change the direction, does not change the speed. Okay, okay, we talk about the other one, AN. So AN, how to calculate delta Vn normal. Delta Vn, actually we can do it like this. Delta Vn, if we take it as a scalar, okay, for simpler, n is on a circle. When you imagine in a circle, the center is here, and this segment is a arc, right? Very small arc, arc, okay, arc. The arc length. So for this small arc, the arc length, we use the green color. The arc length is theta. Theta is d theta, right? And we also take it as delta theta, right? Delta theta. Delta d theta, same thing, okay? This is the angle. The arc length of this velocity is angle times the radius, right? What is the radius? Radius is v plus dv, right? So it is v plus dv, also delta v, right? And delta v. And delta theta times v plus delta theta times delta v, okay? And since delta theta times delta v is much smaller than delta theta times v, we just delete this part because it has a higher order, okay? In Mandarin, it's a 高阶无穷小, right? It's really small, but we put two delta together and we say multiplication, and it just right, that's a higher order smaller than this one, right? We just eliminate this one. We have this one. This one is delta v. Delta v in direction, right? This is delta v in direction, not in speed, just in direction, not a magnitude. So delta theta times v. Okay, so we can calculate now AN, A normal, is this one, delta theta times v, right? Delta theta times v over delta t. So delta theta over delta t, omega, right? And times v. So we have VAN is omega times v. Also, we know velocity equals to omega times r. Therefore, omega times v equals to omega times r, which is omega square r. Therefore, we have these two equations. So I want you to remember, simply just remember this one and alpha r. Okay, just these two. Okay. What you need to remember, I just highlight in red. You just need to remember these two rules here. And for the rest, as long as you have these two, you can refine to other points. 10 minutes break. And later we will have some examples.